So let's do a few more problems before we conclude. Teacher was so glad that last time in the gardens he just pulled out his harmonica, and there we go, the student, actually the one who's videotaping, and he just pulled out his pocket the harmonica, and we just tried, both of our beginners, start doing a little bit of practice. That was beautiful. Should I do a little bit more? Huh? Just for 3 minutes? You can do it better every time if you really try. And in the beginning you don't feel like doing it, but then after you will like what you're making, right? It will make you happy. And you can have it in your pocket, and whenever you don't feel like so good, say, I'm going to make a conscious effort to become happy right now. Just pull it out of your pocket, start making a little bit of noise, and then it's going to get better and better. This is a good tool to get out of that darkness. And teacher is so glad to see some students get a harmonica and have it in their pocket. Our times require this. It's an absolutely necessary thing to do in our time. And you know very well what the pressures are. And if we don't watch out, we're going to have engine come out of the car. Then the car will lose its engine if we don't do our own careful. So here's a good problem we're going to do now. And that is, as you can see, is actually, what kind of law is that? What Hess law, right? Which we said, Hess law is nothing else really but the application of the first law of thermodynamics, right? So what do we have? We have two general chemical equations, and we have delta H, not the number, but the letters, doesn't matter. And then, if we know that X is a negative number, to predict if the reaction, which is represented by the this chemical equation, is exothermic or endothermic, right? So we have two chemical equations representing two reactions with delta H given to us, as you can see in the figure. And we want to know what is, if it's exothermic or endothermic, this, the reaction is represented by this chemical equation. So the only thing we can do is to try to manipulate the two equations we have already from the problem in such a way that when we add them, we're going to get these equations, right? And that way, we can actually add the two delta H's after they are correspondingly altered, and we see what delta H3 for the new equation will be. If we can make up a conclusion, if it's going to be endothermic or exothermic, right? See if it's going to be positive or negative, because that will tell us if the reaction will be exothermic or endothermic, right? Delta H. By knowing what X is, what property X is, there's a negative number, right? So we want this equation, and we want actually on the left we have 6a, and what we have is an equation that has 2a, and that means we would like to have 6, we'll multiply the first equation both sides by 3. So that is going to become like this. So first equation becomes, after it's multiplied by 3, so first equation times 3 will give us 6a, which we wanted because that's what we want to have at the end after we add things. 6a, I don't have to follow the physical states to make my life easier and faster when we do the exam. You don't need the physical states right now. Physical states are important for thermochemical equations, right? But as you try to work out the problems, you don't have to carry it on. So 6a plus now will become 3. It will give us 3c, right? Plus 3d. Now you have to be careful. Delta H, 1 is not going to stay the same, right? It's going to be also multiplied by the same number. So delta H3 now, we'll call it delta H3 because the equation has been altered. So that's delta H is for this equation, that's why it's going to be subscript 3, different. It's not the same, right? It's going to be 3x plus 6y, right? Multiply the coefficients by 3, you also have to multiply delta H by 3. Great. Okay, now, what we want to see? We want to have, in our equation, we need to have 3b, right? So, we already have 3b, that's great. We already have 3b. That which we see is, in our equation, right? We do not have, as a product, C. We don't have C. And here we have C. So we don't want that. We want the other equation to be altered in such a way that C is going to be eliminated. So actually we want the other equation to have C as a product, right? Otherwise how is it going to be eliminated? So the other equation will have to have C on the left, and since it's already 3 there, and we want 3 to be able to eliminate it, we just have to reverse it. Can you see that? If we reverse it, then that will be everything's fine. So, second equation is the reverse. And if you reverse it, then you will have 3c giving you 2d. Because that way this and this will go away when you add them. We don't want it to have 3c. We don't have anywhere 3c. And by reversing it, then delta H in this case is going to be different. So let's call it delta H4. And because we reversed it, this is going to be the opposite sign. So if it's the opposite sign, then it's going to be minus 4x minus 6y. Right? So now you can see the way we thought, if we add the two equations we have now, we have actually this equation that we were looking for, right? We have 6a plus 3b. There's nothing here. The products are there. 3c is gone. It will give us 3d plus 2d that will make 5d. So we can put it immediately. We don't have to write it again. So 3 and 2 makes 5d. Okay, so that's the equation, comes from these two. Therefore, the delta H of this equation is going to be the sum of these two according to conservation of energy as well. So for this equation, therefore, it's going to be delta H. Let's call it delta H5. That's a new equation. Well, actually, does it give us a name there? How to? No, it doesn't. So we can call it delta H5. It will be the sum of these two, right? So it's going to be 3x plus 6y plus minus 4x minus 6y. And if you do that simple algebra, you will find out that delta H5 is actually minus x. And because the problem is telling me that x is negative, therefore, delta H5 standard is a positive number. Since delta H of that equation is a positive number, that means that the reaction is endothermic. Endothermic. Teacher wishes you, when you graduate, to go into something that when you do it, you will be creating, and you will have the joy of creation. You will see something that you are the only one who did it. Nobody else has done it. You know what a joy is? Teacher feels that way many times. You can look around and find out a problem like that before he gave it for first time in this campus. You won't find any problem like that. Nowhere. when you love to do something, you create something new. He loved chemistry, mathematics when he was in high school, was his favorite, right? So he likes math. So he introduced the idea of math into the chemistry. There you go, combination, right? You create something new. You study physiology. What does that have to do with art? Well, you can get a biology degree, and you can get a minor or a major, 2 majors in art. You can combine them. You can teach or do something in biology or physiology, whatever in science. And at the same time, you can start drawing bones and all kinds of things that nobody can really do that. Because you have the knowledge in physiology, right? And you have that component. And you combine these two things. You can combine anything. Anything can be combined and make a beautiful creation. Wherever you are. It's beautiful. And this opportunity is in every university now. You can really take classes wherever you like. Drop the classes you don't like at all and take classes you love. Sometimes you might have to take a class that you hate and you don't like it to reach your goal, right? Sometimes. But that should be an exception. It should not be a continuous struggle for 4 years to take things you don't like. That means something is wrong. Something is happening is wrong, right? It's okay. You might have 1 or 2 classes you don't like, that's fine. I mean, that's life. Sometimes to reach the goal, it's not pleasant all the time, right? But if it's a struggle all these 4 years to do something that you really don't like, and you will go somewhere you don't like it, well, we've got to change. We've got to probably change the major. Very carefully and talking to some people that have some experience, right? Okay, let's do a few more problems. Let's do this problem about solid state. Oops. There you go. Okay, so in this problem we have a face-centered cubic system. We want the fraction of the volume of your silver ring. That means it's not occupied by silver atoms. These problems are really not that hard. If you have solved 1 or 2, you really know how to do it. It's not something kind of that hard. Okay, let's start with what the problem is giving us, right? What does the problem give us? It gives us that we have a face-centered cubic system, right? See what we have, and then we see how we can use what we have to find what the problem was. If you have a face-centered cubic system, we talk about vacuum, empty space or occupied has to do with atoms in the unit cell, right? So how many atoms do we have in the face-centered cubic cell unit? How many atoms? Contribution. Total. How many? 4. So we have 4 silver atoms. 4 silver atoms per unit cell. Also, where we have something else, we might use it, might not use it, but it's good to really put it down. And that is the relation between the radius of the atom, right, and the age of the cube of this unit cell, right? And in your exam, you will have all of the 3 equations that they relate these 2 parameters, but it will not tell you which is which goes to which. You should really remember. And the way you remember it is if you derive it 1 time, then you will remember, okay, how it goes. You will be able to visualize and remember it. So for the face of the cubic system, we have the relationship between the radius and the age of the cell to be given by this equation, right? So we have this and we have that. And in order to find fraction, we need to find out 2 things. The volume of the unit cell and the volume that is occupied by the atom, right? So volume occupied by the silver atoms. In the unit cell, it will be